Our final video for this chapter will look at confidence intervals that are found within normal distributions. So we're going to begin with an example of a hypothetical scenario. Let's say that I conduct a poll to see if my students like tofu as much as I do. And I find that 43% of my students do not like tofu. I don't know what's up with you guys. Tofu's great. It absorbs any flavor you give it, but hey, that's what the results said. And let's suggest then also that I say that the results of this survey are accurate 19 times out of 20 within plus or minus 3%. So let's just kind of dissect what this language means. So 19 times out of 20 means that there is a 95% confidence interval associated with that. Because this comes out to 0.95. And this, plus or minus 3, is something called the margin of error. So what that means is that really the 43% can go plus or minus 3% either way to give me a range of answers between 40% and 46%. There's a 95% chance that will be true. Okay, 95% chance it will be true that within my class, between 40 to 46% of my students don't like tofu. Clearly, I need to start cooking for you. All right, so what we want to do is we want to explore confidence intervals in a number of scenarios. And what I want you to do is go to this link, it's in your notes as well, and watch that little video just to introduce you to something called margin of error. For the sake of moving on in the lesson, I'm going to pull out some of the three key things I want you to learn about these margin of errors and what affects them from that video. So the first thing that can affect margin of error is the confidence interval that is selected. So again, we're kind of talking in circles here, but we'll tie all these terms together by the end, I promise. Confidence interval selected. The sample size plays a huge role. And the variation within the population. Especially if you're working with mean values. I'm going to write that in here too. And again, we'll tie this all together in just a few moments. So let's go back to confidence intervals or confidence levels for a moment. There are three main ones that we want to concern ourselves with. We want to concern with 90% confidence interval, a 95%, and a 99. And I've kind of drawn a visual here for you about what this is really about. What it means is that if I have some measurements like this, where I've taken a measurement, but it could be off plus or minus a certain amount, 90% confidence interval means that 90% of my data points, and I'm just going to draw a few in here just to give you the idea, will contain the mean. Or we can put a proportion here too. We can view the curve as being out of 100 rather than just having a mean value. We'll get to the means versus proportions and compare them in this lesson as well. Okay, so there would be 90% of them that would include the mean or p. 95% are more aligned, and 99%, almost every single one of them would include, obviously 1% would not, would include that mean value in that measurement. Okay. So confidence intervals are ranges of values in which we're going to find the mean or a proportion. Okay. We need to learn about some relationships here. If we want to find the margin of error, in other words, what is that plus or minus value? It depends on whether we're using means or whether we're using proportions. If we're going to use means, margin of error can be found by multiplying z times standard deviation all over the square root of the number of trials. And these are variables we've been working with all throughout the unit. If we're working with proportions, the equation for finding the margin of error is equal to z times the square root of p times q all over n. Okay. I've got a couple other versions of that in the note as well, but these are sort of the simplified versions here, means and proportions. And again, this is for finding the margin of error. Now, when we're finding the margin of error, in order to find those z-scores to put into this equation, we need to know the relationship between z-scores and confidence intervals or confidence levels. And there's a little chart in your note that shows this. And again, this would be given to you as well. It shows that the z-score for a 90% confidence interval that you would use in your calculations is 1.645. For a 95% confidence interval, it shows it at 1.960. And for a 99% confidence interval, you would use a z value in your calculations of 2.576. So again, easy enough to use once you know what confidence interval you're going to choose in a particular question. So I say, hey, let's get to the examples to show how all of this works. In our first example, we're going to use delivery times. And we're going to look at a chain called Pizza King. Okay, so Pizza King knows that its standard deviation for wait times, which I'll put here, is 9.4 minutes. Okay, it also discovers that if there are 30 trials, that the mean, and this is for a sample of deliveries, so I'm going to use this notation instead of mu, which is fine. Okay, is equal to 23 minutes. Okay, so the mean's 23, standard deviation of 9.4. If they want to advertise their delivery times in a relatively good way, in a 90% confidence level, what wait time should they suggest that their pizzas will be delivered between? What's the minimum and what's the maximum time? So with a confidence level of 90%, we can use our table that I showed you previously. It's also in your notes. That corresponds to a Z value of 1.645. So let's calculate the margin of error. I'm going to call it the MOE for short. Because we are working with standard deviation, mean, and therefore means and not proportions, we're going to use this equation of Z times standard deviation over the square root of n. So I'm going to have 1.645 times 9.4 minutes divided by the square root of 30 deliveries, 30 trials. Okay? And when I do this, I discover that the margin of error comes out to 2.8 minutes. I chose to stick with 1 decimal place because the standard deviation was to 1 decimal place as well. So what that means is that the mean can have plus 2.8 added to it to get the range up to delivery times. It could also have 2.8 subtracted from it. Okay, so let's sub in, instead of that symbol, let's put in 23. So if we add 2.8, we're going to get to 25.8 over here. And if we subtract 2.8, we're going to get to 20.2 over here. So therefore, they should advertise their delivery times. Of course, in the ad, they're probably not going to tell you it's a 90% confidence level. That's the lowest of the 3. Okay, and obviously this would change depending which confidence level you use. They're using the lowest one. They should advertise that their delivery wait times are between, we'll just put it in this notation, somewhere between 20.2 and 25.8 minutes. Now again, on TV, they're probably not going to use decimals. They'll probably say between 20 to 26 minutes. If they used a higher confidence interval, that's going to increase the Z value, which is going to increase this, which is going to make this bigger as well, right? So they want to try and keep it as narrow as possible. They don't want to say, oh, it's going to be sometime between, like 10 and 30, right? And I'm exaggerating when I say that, okay? All right, so we found the margin of error using means. let's try it now using proportions as well. Let's go back to our friend Pizza King, and let's say Pizza King surveys 400 people, so let's let n be 400, and they found that 48% prefer their pizza to any other kind. So they prefer Pizza King as their primary pizza delivery place or their place to buy it. So we can go use percentages directly or proportions directly instead of having to change them to decimals, which is quite convenient. So we can do 48% here, and that would mean that our Q value is 52%. Okay, we're supposed to construct a confidence interval. That's one of these for a 95% confidence interval and interpret these results. So let's do that. The confidence level is going to be 95%. We need to convert that into a z-score so we can do some calculations. According to our table, that corresponds to a z-score of 2.576. So, to calculate the margin of error using proportions, we use the equation z times the square root of pq all over n. And this is a good time to interject and say these equations would always be given to you on a summative assessment. Okay? You just have to be able to know how to use them. Let's plug in some values. So this time we have, I jumped the gun here. I used 99% instead of 95%. Let me just change this z value, sorry. For 95%, it's 1.96. So let's plug it in, 1.96. P is 48, and again, we can do it directly, which is kind of nice. No changing to decimals. 52. All over n, which is 400. Okay, so you would do all of this and multiply by 1.96 at the end. That's what I would do for order of operations. And it will come out as a percent because you put in values here that were percents. So it'll come out to 4.9%. That would probably get rounded up to 5%. If they want to advertise to the nearest percent. Okay. So to create that confidence interval, we have to put P in the middle. P is 48. We have to add 5% one way and take away 5% the other way to get that, that confidence level, okay, for 95%, minimum and maximum. This will come out to 43. This will come out to 53. And so a better way of just communicating it as a final answer is that would be 43 less than or equal to P less than or equal to 53. And there's your confidence interval right there. All right, let's go on to another example. Let's get away from pizzas and let's switch to assembly lines because this is a great application of where this is used in industry especially. It can also be used with surveys in psychology, sociology experiments as well. Okay, but we'll go to the assembly line for a moment. This time we want to learn to calculate the sample size that's needed for certain confidence levels. And again, calculating sample size can be done when we're working with means. It can be done when we're working with proportions. Let's take a look at this example. This one says, suppose you've got a sample of bolts. There's a confidence interval of 95%, suggesting that the mean is somewhere in between 7.51 at the low end and 7.55 at the high end. Okay, if you're measuring their diameter, and you want them to be, of course, fairly consistent, or else construction industry might get a little upset with you. Okay, let's take a look at what this width of this interval is. We'll call it W. Okay, the width of this interval would be 0.04. Okay, so if we wanted to express this with a margin of error, what we could do is we could do the mean like this, which of course is the middle between these two. This would be 53. And we could do plus or minus half of that width, because half of it has to go above and half of it has to be below. So it would look like this. This is the margin of error. So it's good for us to realize right here that this width and margin of error have a double and half relationship to each other. Okay. So let's suppose that these bolts have a standard deviation of 0.1 millimeters, a tenth of a millimeter. How big of a sample would you need in order to have be 99% confident that the mean diameter is this plus or minus 1? Okay, so I'm just going to put a break here. This was a little bit of background information here. And here's the true question. So this question changed the confidence level from being 95, sorry, I should have that as confidence level, not interval, okay, to 99, which means if we look up the z-score that corresponds with that, z is equal to 2.576, and again, the width for this new question would be, because it was plus or minus 0.01, the width is double the margin of error. Double would be 0.02. Okay. This question wants us to find out how many bolts would you need to test in order to be 99% confident that they all fall within this range. So the equation for the size of the sample is n equals 2 times z times the standard deviation all over w quantity squared. At this point, we just need to sub in some numbers. So 2 times 2.576 times 0.1. Our width is 0.02 and squared. So make sure you do all of this before you do squared. And you should end up with 663.4 bolts being, or sorry, 0.6 bolts being tested. Quite quickly, you can't test 0.6 of a bolt, so you would round that up, and you would say that you need approximately 664 bolts to test in order to make sure that these measurements give you a 99% confidence interval. Fewer than that might not give you the 99. Okay, let's do one more example together. So this time, instead of using means and standard deviations, we're going to calculate sample size using proportions. We'll go back to our Pizza King. Let's say Pizza King wants to narrow down the width of their interval. They want it to be 2% instead of being 10%. You may remember from previously it was +5, -5. There was a 10% range in there. Okay, they want to squeeze that down. Okay, how many people are they going to have to survey before they discover if they can get a 95% confidence interval and squeeze down the width of that interval? Well, let's go back to that question had a confidence level of 95%, which corresponds to a z-score of 1.960. Okay, let's let our width be 2% because we can work with percents. Let's let P be 48% from that question and Q be 52% from that previous question. All right, so again, we're finding sample size using proportions this time, not using standard deviations and means. So n equals, and this is a new equation, it's given to your notes. Again, these would always be provided to you, okay? N equals 4 times P times Q times this Z over W quantity squared. At this point, it's just a matter of subbing in for variables. So 4 times 48 times 52 times 1.960 over 2 quantity squared. This is just calculator work at this point. The number we get is 9,588.6. Obviously, we can't survey 0.6 of a person, so we're going to round that up, but we're going to say you would need to survey 9,589 people. to try and get accurate results that are within that 95% confidence level, but that have a margin of error width, if you will, of only 2% instead of 10%. And that's it. That's how confidence intervals work. Enjoy your final lesson of practice for the course, and contact me if you have any questions.